So what is meant by spontaneous reaction? The reaction which takes place suddenly without any external input is called as spontaneous reaction. Are you able to understand? It means external input, external energy need not be supplied in this condition. Are you able to understand? Or you can say that when this spontaneous reaction occurs, energy will be released by the system. Energy will be released by the system. System releases energy. Are you able to understand? For example, how can you say, if I release this pen, I doesn't require any external energy to make this pen to fall down, no? So it falls down naturally. And this pen, is it releasing energy or not? Releasing energy. What kind of energy? So its potential energy is reducing, no? Initially at this height it has some potential energy. Now when it reaches to the ground, its potential energy reduces. So it is releasing some kind of energy. Water always flows from high region to low region. This is a natural process. So such type of reactions which doesn't require any external input, they are called as spontaneous reactions. Are you able to understand? Now we study a very important parameter which is called as Gibbs free energy. Okay, ma? Gibbs free energy. So what is meant by Gibbs free energy? It is given by G is equals to H minus Ts. G is called as Gibbs energy. H is called as enthalpy of the system. Okay, ma? T is called as temperature and S is called as entropy. Are you able to understand? Okay, so what is this Gibbs energy? Or you can write delta G, change in Gibbs energy. Delta G means what, ma? Change in Gibbs energy can be written as, how I can write? Change in enthalpy minus T multiplied by change in entropy. So I can write like this also. Are you able to understand? So here I can write, so the change in Gibbs energy, the change in Gibbs energy is a measure of spontaneity of a chemical reaction. Okay, ma? It is a measure of what, ma? It is a measure of spontaneity of a chemical reaction. So how spontaneous a chemical reaction is, that is measured by what? That is measured by change in Gibbs energy. Are you able to understand? So here I can write down, see ma. So Gibbs energy is an extensive property. So a question can be asked on this also. Okay? Gibbs energy is an extensive property. What is meant by extensive property? In thermodynamics we studied, no? Extensive property means what? Extensive property means it depends on mass. Okay, ma? So if a property is depending on mass, it means if mass increases, Gibbs energy also increases. So such type of property is called as extensive property. Clear, no, ma? But Gibbs energy per mole, Gibbs energy per mole, this is an intensive property. Okay, ma? Gibbs energy per mole is an intensive property. What is meant by intensive property? Now already we have taken energy for 1 mole, no? Energy we have taken for 1 mole and it is always a constant. So now it doesn't depend on mass. So intensive property means what, ma? Now it does not depend on mass. Okay? Because we have taken specifically, no? Specifically. So in heat topic also we study, no, ma? Heat capacity depends on mass. Specific heat capacity doesn't depend on mass. Same concept here also. Gibbs energy depends on mass. Gibbs energy per mole doesn't depend on mass. Are you able to understand? Okay. Now here, when can I say that depending on Gibbs energy, whether a reaction is a spontaneous reaction or not. Clear ma? So delta G gives free energy if it is negative, okay ma, or change in entropy if it is positive. In these two conditions, reaction will be spontaneous. Are you able to understand now? So in which condition this reaction, chemical reaction, will be spontaneous ma? When delta G is negative. Change in Gibbs free energy if it is negative, then chemical reaction will be spontaneous. Are you able to understand ma? Delta S means what? S means what? Entropy. So change in entropy if it is positive, then also reaction will be spontaneous. And what is meant by spontaneous reaction already we have written ma? Spontaneous reaction means what? So it happens without any external input, or when this reaction happens there will be release of energy. Are you able to understand? That's it. Now see ma, now let us study about this equation. So the equation of Gibbs free energy is H minus T into S. And what is meant by H already we have studied now ma? H means what? Enthalpy is equals to total internal energy plus P into V. This is called as enthalpy, no? You should not forget this one. Enthalpy means the sum of total internal energy of the system plus the total work the system can do. Okay? The unit of work is, the formula of work is pressure into volume only, no? So total pressure multiplied by total volume. Are you able to understand? So this sum of U plus P into V is called as enthalpy. Okay? So change in enthalpy, how can I write? Change in enthalpy is equals to change in internal energy plus P, change in volume, P delta V. I can write like this. Already we studied in thermodynamics all these topics. Clear now? So now in which condition a reaction will be spontaneous ma? When change in Gibbs free energy is negative or change in entropy is positive. In these two conditions reaction will be spontaneous. Now let us study how Gibbs free energy can be positive or Gibbs free energy can be negative. So in which process the reaction is spontaneous or in which condition it is not spontaneous. Okay, now see. So delta G is equal here. So everything, the sign of delta G should be what? It should be negative. Gibbs free energy should be negative, no? Then only the reaction will be spontaneous. So this delta G will be negative and it depends on two conditions. What are the two conditions? One is the sign of delta H and the sign of delta S. Are you able to understand? So right. So the sign of delta G depends on what? Depends on signs of, okay ma, delta H and delta S. Okay. So let us take both conditions ma. So delta H and here I will write delta S. So let us take one is positive, another one is also positive. First condition. Second condition positive, negative. Third condition negative, positive. Fourth condition negative and negative. Okay. So in these four conditions we will try to understand whether delta G will be positive or not. Okay. If it is positive, it is not spontaneous, and if it is negative, then the reaction will be spontaneous. Are you able to understand? So let us substitute each of them. Okay. So let us take case number 1. Case number 1. What is case number 1? Delta H is positive. Delta S is also positive. Are you able to understand? So therefore delta G is equals to delta H minus T into delta S. Are you able to understand? So if both values are positive, then how can I write delta G is equals to plus delta H minus T into plus delta S. I can write like this now. This is the equation. Now can you say in this condition delta G, can it become negative or not? ఇప్పుడు డెల్టా జీ నెగటివ్ అవుతుందా అవ్వదా చెప్పండి. ఓకే, సో వాట్ వీ హ్యావ్ టేకన్ డెల్టా హెచ్ ఆల్సో పాజిటివ్, చేంజ్ ఇన్ ఎంథాల్పీ ఈజ్ ఆల్సో పాజిటివ్. ఓకేమా, చేంజ్ ఇన్ ఎంట్రోపీ ఈజ్ ఆల్సో పాజిటివ్, both are positive, then this is the equation which I get. Now by looking at this equation, can you say delta G, can it become negative or not? Because we want a negative value only, no? If delta G is negative, then only reaction will be spontaneous. Are you able to understand? Ma? Can delta G, can it become negative or not? No. It can become. In which condition it can become? Ma?
Delta S is more, sir.
Delta T is also there.
It is minus 1, sir.
So?
It can be minus only then, sir.
In which condition delta G can become negative? That is my question. Can it become negative or not? Sima, this is 5, this is 2. 5 minus 2? 3. Value is positive. No? But if it is 5 and if it is 6, now can it become negative? Now definitely it will become negative. No? It means the magnitude of T into delta S should be greater than delta H. Clear, Nama? The value of T into delta S, if it is greater than delta H, then delta G will become negative. Are you able to understand? So therefore what I can write, okay, for delta G to become negative, magnitude of T into delta S should be greater than magnitude of delta H. I can write like this. Is it clear, ma? So in this condition, now what I can say, delta G will be negative and reaction will be what, ma? Reaction will be spontaneous. Are you able to understand? So same types of questions will be asked in the examination, ma. Are you able to understand? ఇవే క్వశ్చన్స్ ఇలాగే అడుగుతాడు ఎగ్జామ్. ఓకే, ఎందుకంటే కెమిస్ట్రీలో అంతకుమించి ఏం లేదు కాబట్టి ఇవే క్వశ్చన్స్ అడుగుతాడు. క్లియర్? Now see ma here, so therefore can I say that T is greater than delta H divided by delta S? Can I write like this? Okay, so if T into delta S is greater than delta H, definitely I can write this relation. If delta S, if I send to the other side, then it will become delta H divided by delta S. And this temperature at which reaction will become spontaneous, this is called as spontaneous temperature, or the temperature at which the reaction will become spontaneous. Are you able to understand, ma? So at this temperature, when temperature is greater than delta H divided by delta S, the reaction will be spontaneous. Are you able to understand? So make a note. So this temperature is the temperature at which reaction will be spontaneous. Are you able to understand me? Clear? Now let us try to apply the second case. Second case is what? Delta H is positive and delta S is negative. Are you able to understand me? Come on, first make a note up to here. Delta H is positive, delta S is negative. Are you able to understand? So here I have to write negative value. Okay, so negative value, what is the total answer I will get here? I will get, so delta G is equals to delta H plus T into delta S. This is what I get. And here temperature should be measured in Kelvin, no? Negative Kelvin possible అవుతుందా? Negative of a value of Kelvin, is it positive? Is it possible? Kelvin starts from 0 only kada. Minus 20 Kelvin is not possible. 0 Kelvin is possible. So temperature is not negative, delta S is not negative, delta H also not negative. Are you able to understand, ma? So total value I got a positive value, so delta G is positive, so reaction is not spontaneous. reaction is not spontaneous in this condition. Are you able to understand? Similarly, write the third condition. Okay. So what is case number 3, ma? Case number 3, negative, positive. Okay. So this value I will take negative value and this value I will take positive value. Clear? So minus delta H minus of T into delta H. So what is the total value? So this is also minus, this is also minus. So definitely delta G will be negative and it is a spontaneous process. Are you able to understand? Delta G negative రావాలి అదే కదా మనకు కావాల్సి. So definitely this is a spontaneous process. Are you able to understand? Similarly, substitute the fourth case and see what is the answer you will get. Fourth case is negative, negative. Substitute just student. So case number 4, negative, negative. This is also negative and this is also negative. Clear nama? So negative and this value is also negative. So negative minus of minus will become plus. Are you able to understand? So now in this condition, delta G, can it be negative or not? Can it be negative? Magnitude of delta H should be greater than the positive value. If negative value is greater than positive value, then in that condition delta G will be negative. That's all. No? So here what is the condition? Delta H should be greater than T into delta S, then delta G will be negative and reaction will be spontaneous. Are you able to understand? No? So these are the different conditions in which a reaction can be spontaneous. Clear, no? Okay. So keep the next side heading. Okay, very, very simple concepts, ma. Okay. So next we will study about standard Gibbs free energy. Okay, ma? So Gibbs free energy at a particular temperature and pressure is called as standard Gibbs free energy. Are you able to understand, ma? So what is the temperature? That temperature is 25 degrees Celsius and pressure is 1 atmospheric pressure. Are you able to understand, ma? So at 25 degrees Celsius temperature and 1 atmospheric pressure, what is the Gibbs free energy? That is called as standard Gibbs free energy. Are you able to understand, ma? So temperature is written in Celsius, no? If I want to convert into Kelvin, what I have to do? Kelvin loki marchalante 25 plus 273. So total how much, ma? 298 Kelvin. Clear? So therefore at a temperature of 298 Kelvin and 1 atmospheric pressure, the Gibbs free energy is called as standard Gibbs free energy. And it is represented by this symbol, delta G degrees or dot or star, anything you can call it. Clear, number? So therefore I can write, so standard Gibbs free energy is equals to, so delta H star minus T into delta S. Are you able to understand, ma? So this is called as standard Gibbs free energy. Okay, just at a particular temperature and at a particular pressure. Which temperature and which pressure? 298 Kelvin and 1 atmospheric pressure. Are you able to understand, ma? Now here there is one important point which we have to study about standard Gibbs free energy, ma. Note point I will write down here. Note point is that at equilibrium, okay, ma? We know what is meant by equilibrium of a chemical reaction, no? What is meant by equilibrium? Yesterday only we discussed. Equilibrium means what? The concentration of reactants and concentration of products, if it is not changing, then such type of reaction is called as equilibrium. Are you able to understand, ma? So at equilibrium, Gibbs free energy will be 0, but standard Gibbs free energy may be 0, may not be 0. Okay, ma? This is another important point which you should remember. Are you able to understand? So at equilibrium conditions, Gibbs free energy is 0 definitely. But standard Gibbs free energy may be 0, may not be 0. Clear, Nama? So then we write another important point. Okay, ma? So standard Gibbs free energy, standard Gibbs free energy is taken 0 for elements or molecules okay, ma? When they are in their natural form. Okay, or you can call this one as standard form. Are you able to understand? So Gibbs free energy is taken 0 for those molecules or atoms in which they are present in their natural form. Are you able to understand? Now let us see what is meant by natural form. Okay, Sima. Oxygen, naturally it is present in the form of gas, no ma? Oxygen natural ga gas form lo untunda, liquid form lo untunda, solid form lo untunda. Gas form there, no? So therefore its standard Gibbs free energy will be how much? It will be 0, because oxygen is present as O2 and in gaseous form in its natural form. Oxygen alage kada manu dorkedi. Clear, no ma? But if you take H2O, here also oxygen is present, no? Here also oxygen is present, but is it in its natural form? No. So therefore its Gibbs free energy is not 0. Okay. So here I have written elements or molecules, ma. But molecule means molecules not made up of different elements. Molecules made up of similar elements. This is also a molecule and it is also in its natural form. Are you able to understand? But it is not made up of single element, it is made up of multiple elements. Hydrogen is also there, oxygen is also there. Okay. So for such elements we are not studying Gibbs free energy. Molecules which are made up of same element. Oxygen molecule, it is a molecule only, no? But it is made up of what? Same atoms of oxygen. For such molecules, and if they are present in a natural state, then definitely we can say their Gibbs free energy is taken to be 0. Are you able to understand, ma? Similarly, same oxygen, if I take in a solid form, is its Gibbs free energy 0, ma? Oxygen ni solidify చేసినాం అనుకోండి, గడ్డలాగా చేసినాం అనుకోండి, ఇట్స్ గిబ్స్ ఫ్రీ ఎనర్జీ 0 అవుతుందా అవ్వదా? అవ్వదు. ఎందుకలా? No, because it is not present in its natural గా అది గ్యాస్ లాగా ఉంటుంది. క్లియర్ నమ్మా? సో దేర్ ఫోర్ ఇట్స్ గిబ్స్ ఫ్రీ ఎనర్జీ is not 0. Are you able to understand? For example, if you take hydrogen naturally it is present in gas form, nama? So its standard Gibbs free energy is 0. Are you able to understand? So like this you can write many substances. For example, if you take bromine, in periodic table we have bromine, no? Naturally is it solid, liquid or gas? Bromine is a liquid. Are you able to understand, ma? Naturally it is present in liquid form. So therefore its standard Gibbs free energy is 0. Okay. Similarly, if I take sulfur, if it is present only in a rhombic form, then its Gibbs free energy is 0. Many other sulfurs are present. So monoclinic sulfur is present, but its Gibbs free energy is not 0. Similarly, triclinic sulfur is also present. Its Gibbs free energy also it is not 0. Are you able to understand, ma? Similarly, I take phosphorus. Okay, white phosphorus only, its Gibbs free energy is 0. Okay, there are many phosphorus. So black phosphorus is there, red phosphorus is there. For of them, Gibbs free energy is not 0. Are you able to understand, ma? Similarly, one more note point I can write here. Note point is that, okay, only one form of allotrope is taken 0. Okay, ma? So, for example, carbon can have many allotropes, no, ma? అదే కదా ఇప్పుడు మీకు జరుగుతుంది కార్బన్ కెమిస్ట్రీ. Many allotropes are there. Are you able to understand? Out of them, the allotrope of only one form is taken 0. Gibbs free energy is taken 0. For other forms, it is not taken 0. Example is what? So, if I take carbon, graphite form. So, its Gibbs free energy is how much? Its standard Gibbs free energy is taken 0. Okay, ma? Carbon can be present in diamond form also, no, ma? Diamond is also a form of carbon only, no? But its Gibbs free energy is not 0, like this. So, for same element, many allotropes are possible. Okay, but we take only for one allotrope we take as a measurement. For that one only we take standard Gibbs free energy 0. For the other allotropes, remember in the case of calculation of Gibbs free energy. Is it clear? Let us write one example. Clear, ma? Completed, no, ma, up to here? So, Gibbs free energy, standard Gibbs free energy in a chemical reaction. Standard Gibbs free energy in a chemical reaction. Are you able to understand? So, if some chemical reaction is happening, then the change in Gibbs free energy in the case of reaction can be written as the change in Gibbs free energy in the case of products minus change in Gibbs free energy in the case of reactants. So, this is the formula to calculate Gibbs free energy change in the case of a chemical reaction. Are you able to understand, ma? So, standard Gibbs free energy change in the case of products minus standard Gibbs free energy change in the case of reactants. This is how we can write. Are you able to understand? Let us take one example. One example is, for example, methane naturally in gas form. Okay, it reacts with oxygen to release carbon dioxide and water. So, I can write like this, no? Clear, no, ma? So, see, ma, one very important point, note point here we have to write is all calculations must be done only in balanced reactions only. Okay, ma? Because when reactions are not balanced, everything will be wrong. ఖచ్చితంగా రియాక్షన్ని బ్యాలెన్స్ చేసే మీరు ఏదైనా ఫైండ్ అవుట్ చేయాలి. అది ఎంథాల్పీ కానీ, గిబ్స్ ఫ్రీ ఎనర్జీ కానీ, ఎంట్రోపీ, వాట్ ఎవర్ ఇట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్, మా? నౌ ద రియాక్షన్ ఈజ్ ఇట్ బ్యాలెన్స్డ్, మా? 4 hydrogen, 2 hydrogen. So, I will write 2 here. But 4 oxygens, here 2 oxygens. So, I will write 2 here. Now, the reaction is balanced. Are you able to understand, ma? So, for this condition, how can I calculate the change in standard Gibbs free energy? ఈ రియాక్షన్కి ఎలా రాస్తాం చెప్పండి? According to this equation, how can I write standard Gibbs free energy change? ఎలా రాస్తాం చెప్పండి? Completed, ma, this one? Okay. Anybody, can you say? చెప్పండి. Okay. See, ma, here CH4 means 1 into CH4, no? 1 into CH4 means what? 1 molecule of CH4 తీసుకోవచ్చా? But you should not take. Every calculation in chemistry must be done in moles only. నిన్ననే చెప్పినాను కదా, ఒక ఆటము ఒక మాలిక్యూల్ కాదు మనం తీసుకోవాలి, ఒక మోల్ తీసుకోవాలి. Are you able to understand, ma? So 1 mole of CH4 It reacts with 2 moles of oxygen to release 1 mole of carbon dioxide and 2 moles of water. This is the method in which we have to take. Are you able to understand? So therefore, standard Gibbs free energy of the reaction, how can I write, ma? So the change in Gibbs free energy in the case of products minus the change in Gibbs free energy in the case of reactants. Are you able to understand? So these are the products and this is the reaction, no, ma? So write down. So how can I write down first CO2? How many moles of CO2 is released, ma? CO2. 1 mole of CO2 is released. So 1 multiplied by the change in standard Gibbs free energy in the case of CO2 plus, now what is the second product released? 2 moles of oxygen. So 2 multiplied by standard Gibbs free energy in the case of water, clear, nama? Minus of, now I have to write the change in Gibbs free energy in the case of reactants. Are you able to understand? So how many moles of CH4 is there? 1. 1 into change in standard Gibbs free energy in the case of CH4 plus how many moles of oxygen, ma? 2. 2 multiplied by standard Gibbs free energy change in the case of oxygen. So this is how I can calculate the total change in standard Gibbs free energy. Are you able to understand? Okay. Now see, ma, in this reaction, one change in Gibbs free energy is 0. What is that? మొత్తం 4 ఉన్నాయి కదా ఇక్కడ, 4 terms are present.
Oxygen.
For oxygen it is 0. Okay. Why oxygen it is 0?
It's in natural state.
So this value is 0. What is the reason? Because this is oxygen and oxygen is present in its natural state. Are you able to understand, ma? Oxygen natural ga ela untundi, gas form lone kada undedi. So this is gas only. So standard Gibbs free energy change for this oxygen will be how much? 0. Okay. What about remaining terms? Are they in natural form? Carbon CH4 form lo undi, natural form lo unda లేదు. So its standard Gibbs free energy is not 0. Are you able to understand, ma? Here also carbon is there. Is it present in its natural form? Carbon only if it is present in graphite form, then only its the standard Gibbs free energy will be 0. But here it is present in carbon dioxide form, it is not 0. Hydrogen, is it present in its natural form? No. Hydrogen naturally it is present in molecules in the form of gas. Clear, no, ma? But this is water. So it is also not present in its natural form. Are you able to understand, ma? So like this, you can write the change in total standard Gibbs free energy in the case of a reaction. Is it clear? That's it. Make a note. Undi. At any temperature. ఏ టెంపరేచర్ అయినా సరే.
ఏ టెంపరేచర్ నెగిటివ్ కాదు.
నెగిటివ్ అవ్వదు, కానీ పెద్దది చిన్నది అవుతుంది కదా. బిగ్గర్ ఆర్ స్మాలర్ ఇట్ కెన్ బికమ్. పెద్దది చిన్నది అవుతుంది కదమ్మా. ఓకే, నౌ సీ మా, దిస్ ఈస్ ద క్వశ్చన్. So of the following cases, identify the case in which spontaneous reaction is possible at any temperature. Starting లోనే చదువుకున్నాం కదా మనము. So delta H should be less than 0, delta H should be greater than 0. So that is the only case in which reaction will be spontaneous at any condition. Are you able to understand, ma? So this is my answer. If you want the proof of this one, you can write down here. So delta G is equals to delta H minus T delta S. Are you able to understand? So delta H is negative, no? So minus delta H minus T into delta S. So total reaction is negative, no, ma? Total value I got negative. So this is the only condition in which whatever may be the temperature, this value will be always negative. Are you able to understand? In other cases, depending on the magnitude of temperature, so reaction may be positive, it may be spontaneous, it may not be spontaneous. But this is total value is negative, no? So whatever may be the temperature is always positive, no? Temperature, if you measure in Kelvin scale, always positive. Okay? So whatever be the value of temperature, reaction will be always spontaneous because delta G will be always negative. ఇస్ ఇట్ క్లియర్? సో దట్ ఈస్ ద కండిషన్. ఇందాక ఇక్కడ ఉన్నావు కదరా, బయట నుంచి ఎలా వస్తూ ఉన్నావు నువ్వు? శ్రీకృష్ణులాగా మాయమైపోయినావేమో అనుకున్నా. ఓకే, సో కెన్ యూ సేవా? So in this chemical reaction, delta H is 150 kilojoules, change in entropy is also given, temperature is 300 Kelvin. Then what is the delta G for this reaction? Very tough question. Clear, Nama? So delta G is equals to delta H minus T into delta S. Delta H, change in enthalpy is how much? 150 kilojoules. See, my options are also given in kilojoules. You need not convert here, directly you can write down. Minus temperature is 300, delta S is so 100 joules per Kelvin. Are you able to understand? Okay, so here value is given in joules, Nama, but options are given in kilojoules and delta H is also given in kilojoules. So therefore you convert this one in terms of kilojoules. Okay, so 150 kilojoules minus of, so 3 zeros will make a kilo, no? So therefore 30 kilojoules per Kelvin. Okay, now everything converted into kilojoules only, no? So therefore 150 minus 30 is how much, no? 120 kilojoules is the change in delta G. That's it. Very, very tough question. Clear, no?